Greetings and welcome to TALE Module 3, Unit 4. This is also related to understanding how brains learn. In the earlier unit, we tried to understand a little bit of the anatomy of the brain. Obviously, half an hour is not sufficient to understand all aspects of the brain, which is the most complex what do you call most complex thing in the world as of today. And here, as I said, what we are trying to do is based on a little bit of the very superficial, very simple structure of the brain and the anatomy of the brain, we are trying to see how some features of learning and teaching can be related to the structure and functioning of the brain. That is what we tried to do in the earlier unit. Now in the present unit, we will continue with the process. Some of the instructional methods that facilitate the brain in dealing with information transfer from senses to short term memory. We will presently see, that is, when we receive any information, we try to understand how the brain is likely to process. In that processing, what are the issues that come and whether we can use instructional methods that facilitate the what we call processing the information in the short term memory. We have to define all these terms present. We will do that presently. And before we move on to that, the question should come. We have been, as teachers, we have been working and teaching, and many decisions we have taken intuitively based on our personal experiences which seem to be working. Why should teachers know anything about brain science? Now it is increasingly getting accepted through the research that is going on, that teachers and therefore students also can benefit from better understanding of how the brain works. So the recommendation is, you can have a short course, a 1-credit course that can be offered at some suitable point even to the students and designed for students, so that facilitate them to understand how the brain works. Could be a good idea. But neither the students or teachers need to understand all the intricate processes behind how human brains work. We do not have to work the intricate process. For example, as we said, there are about 100 billion neurons and there are about 900 billion glial cells, and how the energy gets transferred from glial cells to the neurons. All the electrochemical processes that happen or the biochemical process that happen, they need not be understood. We look at the whole thing at a certain level that can make sense to us or to the teachers and students. So what is more important is for teachers to know how humans and their brains develop. Now the way humans develop is influenced by cognitive, and most of it is cognitive experiences. That means some information is getting transferred or being given to us by various means by the teacher, but while this is taking place, there are social and biological experiences simultaneously happening. So whenever we are learning, there are all the 3 dimensions exist: cognitive, social and biological. And all these experiences together decide whether we are, whatever word that you want to use, whether we can make sense of what the teacher is teaching, or it is meaningful to us, whether it will be transferred to our long term memory so that we can recall whenever we want, we remember the process. All these are influenced by cognitive, social and biological experiences. Now while with respect to cognitive, we have looked at in the TALE 2 how do you design the course and how do you We understood something about cognitive dimension in tail module 1 as well. While we understand that, but how do we integrate all this is something if a teacher knows, he can do much more satisfactory or effective instruction. Let us look at a little more of this. Now what happens is what we call cognitive, social and biological experiences, whether they are ongoing or in the past. So there is nothing, because the past significantly influences what we learn right now. It will have a great impact, whether that means these experiences through which we have gone through already and whatever that is going on in the classroom, they shape the way we interpret and process information. And one thing should be remembered, our brains are constantly active. That means it is not a passive one. While you are reading or listening to what the teacher says, different parts of your brain are working to tune out background noises, pay less attention to other people in the room, and overall keep you focused on the words. If the other people are disturbing you, obviously you cannot focus on what the teacher is saying, or there could be very disturbing loud background noises, something happening outside the classroom, and there is no way you can easily, especially when some construction is going on, if they switch on the drilling machine, obviously the background noise will significantly affect whether you can pay more attention to what the teacher is saying. Now that can be interpreted as what gets remembered is the loudest signal, and that means which is the most dominating signal, whether it is a background noise or somebody next to you talking to you or what the teacher is saying. So what gets remembered is really the loudest signal, and these signals can be amplified by things like attention, salience, personal and social relevance. So what happens when the teacher is presenting something, you want to make that as the loudest signal in spite of many things happening around, and that can be done by paying attention to what the teacher is saying, and also you consider it is salient to what that particular course, and also you find both personal and social relevance to the topic that is being addressed. So if you can take care of all, if a teacher can pay what you call consider these four aspects, he can make whatever that is being taught as a loudest signal. For example, another background noise in many classrooms, you have fans going on because it is quite hot, and then you have that noise constantly disturbing what is being presented. Now still there is another issue. Social and emotional factors influence students' cognitive abilities and academic achievements. For example, there are emotional factors that we see will also influence our cognitive abilities. For example, emotional factor can influence you not to pay attention to what is being taught. We will presently see what they are. So an understanding of what is happening, how the information is going to get processed will help the teacher to target social parts of the brain. And how does it in a classroom, the social part, improving the social part of the brain, how do you take care of it? Like you introduce peer work, that means you give a small assignment to 2 or 3 people to work on, or you are tutoring one-to-one instruction, or even incorporating tools like cell phones as a part of this, or other devices or internet devices, but presently thought typically as a distraction. So one can use cell phone very effectively, but provided that you are able to get his attention and they use the cell phones properly. This will be a challenge. Okay. Now these are some reasons why teachers should know about brain science, and in my opinion even the student should know something about it. So when you understand what is happening inside, however superficially, you will be able to react to that situation and see that you benefit from that in terms of learning. Now we will not in this module we will not be looking at all processes, all dimensions of brain processes. We will only look at these 5, namely information processing, memory, learning, retention and transfer. These are the 5 processes are of immediate concern. There are endless number of other things that influence our learning, but we will mainly look at what these 5 processes are. Particularly in this unit we will be focusing on information processing and memory. Now what has been happening is, for the past almost once the computers came into being in 50s and 60s, and the computer metaphor is being used to model the brain. That means there is some input device that where information is coming through senses. So these are all input devices. Then you have a memory, there is something that is processing this information and so on. It looked like a computer metaphor is an appropriate one. People still use the computer metaphor to explain how the information is being processed. First thing is the brain stores information, but the problem is learning, storing and remembering are not fixed processes like they happen in the computer. Okay, there is some part of the memory is used, and then there is a CPU, then you process that information and put it back in the memory. It does not happen just like that in the brain. So you cannot afford to use the computer metaphor for everything. And these processes, learning, storing and remembering, are dynamic and interactive processes. Possibly each time you do any of these things, you are not necessarily doing exactly the same way. Now we require a model that should address how the information from our environment is rejected or accepted by senses for further processing, and how the accepted information is processed, under what conditions it gets stored. For example, if you look at what brain receives information from the environment, in all ways there are endless number of things. Outside, the visual part is continuously changing, we notice that. If you look at it from a computer perspective, within less than a minute, possibly the amount of information that is getting either accepted or rejected will far exceed a big computer that can do maybe handling over a year. That means the brain is designed to reject possibly 99.9% of the information that is coming to you, because you can't help it. All senses keep on accepting, producing the data. So as we said, because there is a rapid proliferation of computers, it has encouraged the use of computer model to explain brain functions. And if you look at even the smallest handheld calculator cannot perform human brain in solving complex mathematical operations. So brain is not designed to perform complex mathematical operations and cannot be in competition with a computer. But computers cannot, as of today. It may happen sometime in the future, we do not know, with all this talk about AI and machine learning and all that. But the computers cannot exercise judgment with the ease of human judgment. The way humans make a judgment, computers cannot do that kind of thing right now. And human brain is an open parallel processing system continually interacting with physical and social worlds outside. It analyzes, integrates and synthesizes and abstracts generalities from it all the time. Every time a new experience comes, we take that information into our existing thing and we will find whether if I find it meaningful, I will re-abstract my generalities. That means my conclusions, whatever I was doing earlier, now can get modified. So the way I keep abstracting can change provided I find the information that is coming to me is meaningful. We will talk about this meaningfulness presently. The another interesting thing about the brain is, it is like if you have a visual image, possibly in a computer will take care of look at it in terms of pixels and then try to save each pixel with regard to the whatever information that you have about the colors, the intensity and so on, but the brain does not store that way. Each thing is a sequence of patterns and some of these patterns are stored in the brain and no pattern may be complete with respect to any whatever you call information, whether it is sound or picture or anything, it is not complete. That means as if any picture is broken into large number of patterns and they are stored, and interesting thing is it is stored at different places and they are somehow linked with each other. That means the brain connects one pattern of one particular image and they links it all of them, and any recalling one piece can activate the whole. That is the interesting part. And much more importantly, emotions play an important role in human processing, understanding and creativity. Emotions play a dominant role. Something like 90% of the decisions, or I am just giving an approximate number, decisions are made emotionally. They are not done every time through logical using certain logic. You do not make decisions like that. If you try to take your decision in everyday activity based on logic, you will never even drink a cup of coffee, because if you logically process that information. So emotions do play a very important role in human processing, that should be remembered. And this is another facet. Ideas generated by human brain often come from images, not from logical propositions. And as I said already, memories are dynamic. That means they constantly change depending on the new information, and they are dispersed over the various parts of the brain. And as new things are getting processed, the brain changes its own properties. As a result of every experience, the brain changes its own properties. So when you look at same information, let us say after some time, after a lapse of time, you are processing it differently, because meanwhile the brain has changed. So it is possible that sometime in future computers will be able to mimic many of these qualities, capabilities and weaknesses of the human brain, possibly maybe in a decade, or we do not know whether it will take much larger number of years. That computer may be designed to mimic many of these features. Now this is the approximate model as given by David Sousa. That is here it is like blinds, sliding blind, and then these are this is from the environment. You may get from any of the 5 senses. Okay, the input comes from any of these 5 senses. First thing is you call this a sensory register if you want. and here possibly 99.9% of the information gets thrown out because it is not relevant to what we are interested, because there is so many. For example, if I am sitting here, I am sitting looking at a whole bunch of chairs in front of me, I am not all that image that is formed, that gets filtered out because it is not relevant. Then whatever that is kind of pushed out, whatever that remains from this will now enter the immediate memory. Now what happens? This past experience will decide what exactly is the one that is to be thrown out. So it is a past experience that decides what is to be thrown out and what should get into the immediate memory, and even the same past experience will also decide, even if the whatever information that I am getting into the immediate memory, quite a bit of it will get thrown out, and only some fraction of that will come into the working memory. And from this working memory, after making a sense of it and finding some meaning, then this information will get transferred to your these are the long term memory. These are presented as filing cabinets. For example, with respect to the same thing, when you store, one element may get into one of the filing cabinets and another what do you call pattern may go into get transferred. We do not know how exactly it happens, and the whole thing is integrated together, and this is what we call all the information that is stored in all these filing cabinets determines what you call self concept. Okay, we will presently see that, and whenever you want, depending on what you are expected to do, you retrieve information from here and bring it back to the working memory, let us say to solve a problem. When you are asked to solve a problem, you will retrieve something from the long term memory, bring it to the working memory and produce an output. Okay, the results of that might be again go back to the storage. Okay. Broadly, this is the one of the current models. We do not say the fully accepted, because all people do not exactly agree whether this is the model. Okay. It is kind of evolving as such. Now let us look at, we have already looked at how the whole structure is. Now we will look at it specifically how the information is getting transferred. So information from the senses passes through the sensory register to short term memory after the incoming information is filtered to determine how important it is. As I said, when you are inside the classroom, something like 99% of the kind of sensory information that comes keeps getting filtered. The filtering of incoming information is dominantly done by past experience of the individual. And the sensory register, or what you call sensory memory, does hold information for a very brief time. That means all the images that are there is temporarily comes into the sensory memory. If the individual finds some of it is very important, your attention will get diverted to that. But usually in less than a second, that sensory memory gets keeps getting clear. And as we showed, the so called short term memory consists of two parts. One is immediate memory and the other one is working memory. There is a tremendous amount of work that has been done on these two, immediate memory and working memory, and some people want to deal it with as a single item like short term memory, and here David Sousa considers these two. It is beneficial, it is convenient to separate in intermediate memory and working memory. Okay. Immediate memory in the model may be treated as a clipboard, a place where information is put briefly until a decision is made how to dispose it of. Somebody stuck it like a post-it note is put on that, and somebody quickly considers that and either removes or keeps it. And intermediate memory operates subconsciously or consciously, holds the data for up to 30 seconds. These numbers, please take it as indicative, not as absolute. These 30 seconds may differ from one individual to the other, but that is the order of the time for which the intermediate memory holds on to the data. And most importantly, threats and emotions affect memory processing. Students must feel physically safe and emotionally secure before they can focus on the content. If sometimes people may not feel safe, but if there is a likely to be a physical threat, obviously the entire attention goes, but emotionally secure, that is more important. In a particular classroom, the student may not feel emotionally secure, in the sense he may feel that this subject is too far above, or the teacher is very intimidating, or whatever feelings that he have. For example, the exams are coming, you are not yet there, so you are emotionally disturbed. All of them will decide to what extent you can focus on the content. And data affecting the survival and data generating emotions are processed ahead of data for new learning. So this is what teachers should really remember, that if data from these two, affecting survival and data generating emotions, when it comes first, that means teacher should also make sure that the student actually feels comfortable with respect to this, then only he can learn properly. So how a person feels about learning situation determines the amount of attention devoted to it. In our earlier unit in the same module, we spent something about learning situations. As you can see, learning situation can greatly destroy the quality of learning. So both the management as well as the teacher need to pay to the situation, because that is what makes a tremendous amount of difference whether the student is going to learn or not. Now we come to the working memory. That means after it is processed out, whatever that is considered important, it comes to the working memory. There is a lot of research done, what is the size of the working memory, and is it the same for all, does it differ from person to person, at what age the size will change, whether there are multiple working memories. All this, there is still tremendous amount of research is going on, but we need not be concerned with that. Working memory is also temporary memory and is a place where conscious processing occurs, whereas in the case of intermediate memory, it could be conscious or unconscious processing can occur. See, the only thing that we need to remember about working memory, it is of very limited capacity. So that what should be remembered, it has our focus and demands our attention. If we try to bring too many things, too many concepts, too many inputs and too many procedures to the working memory, it won't have space. It won't have space, so the person may not be able to, has to push something into the long term memory, deal with the existing one and then again bring it back, that kind of thing you have to perform. So the teacher has to remember, or every individual have to remember, that working memory is of a very limited capacity. And as I already mentioned, information in working memory can come from sensory and immediate memories or be retrieved from the long term memory. let us go back and see. See, from intermediate memory it comes on to the working memory. It can also come from retrieved information from long term memory, and it is like a work table. All this information from retrieved to this, you process that, and if you find it important, like it has sense, you can make sense out of it and it has meaning, it gets stored in the long term memory. Okay. And there are two mechanisms, what you call phonological and visuospatial rehearsal loops. Phonological means it is all any voice type of information that you get. The other is visuospatial rehearsal loops. These are the two major loops that process the information and encode. As we said, it is divided into different patterns, and these patterns are stored elsewhere. All that processing, that encoding the data coming into the memory occurs using phonological and visuospatial rehearsal loops. We will talk about the rehearsal in the next unit. And what is the meaning, what is the implication of limited capacity of the working memory? That is, requires us to do chunking of information. Do not present too many things, large number of concepts, large number of procedures in a given period of time, and then try to solve a problem or expect students to solve a problem. So, you have to break it into chunks. Each one you complete, solve, fully understand, and send it to long term memory, bring the next chunk, and so on. So, if the teacher can keep the number of items related to a lesson outcome within the capacity limits of students, they are likely to remember more of what they learned. Actually, many teachers do that intuitively, but if you are aware of it, you will definitely make sure that you chunk the information appropriately. And even working memory is temporary and can deal with items only for a limited time. You cannot keep information for a long period because you have to make space for the new information to come in. And this also, how much amount of time you are spending to process that information will depend on the motivation of the student, because that particular lesson does not interest me, I am not motivated, I quickly dispose it off. Either I throw it out or only put a bit of that into transfer it to the long term memory. So, broadly you can say packaging lessons into 15 to 20 minute components is likely to result in maintaining greater student interest than one 40-minute lesson. Some may argue, to present something I require 40 minutes at a stretch. Yes, you can do that. It is not as if every time you do 40 minutes session it is the student learning decreases, but it is preferable for an average student to break it into 15 to 20 minute components. That means after that 15-20 minute presentation of something, you change, you make the students do something else, and then come back to the next chunk. And information is most likely to get stored if it makes sense and has meaning. There are two words, sense and meaning. These two are different. Making sense means the learner can understand an item on the basis of his or past experience. For example, in electrical engineering, let us say you are trying to present something like Roth-Hurwitz's criterion, and the entire logic makes sense to the student, in the sense he can follow based on that how the matrix or the equation to be written, and how do you graphically determine the number of roots in the left half plane and right half plane. All such things, the mathematics of it you may follow, but if it does, it may not make any, there may not be any meaning to you, may not be able to find any meaning to you. Say, where am I going to use it? It does not make meaning to me at that point of time. So, something can make sense to you, but it may not mean anything to you. So, having meaning refers to whether the items are relevant to the learner. So, if the learner finds it, yes, I can see what is the where I am going to use, you are going to, if you find it relevant, then you will certainly transfer it to the long term memory. The same item is not, if it is does not make sense to, it does not has any meaning for you, it is not likely to go into the long term memory, but same item is not likely to be equally relevant to all students in a classroom. That should be remembered, because each student is different and his past experience is different. Some students will find it relevant, some students do not find it relevant. So, as we said, sense and meaning are independent of each other. Meaning has more impact than sense making on the probability that information will be stored. Typical example is a television program. You may watch a television program, it may entertain you, it makes sense to you, but it does not make it has no long term meaning for you. So, what happens while you get entertained by television programs, you kind of forget all the details. A person will find it wasteful to store it in the long term memory. And sense and or meaning must be present in some degree for storage to occur. So, obviously, it will not, if you put on a scale of 0 to 1 for both sense and meaning, you in any particular learning that is taking place in the classroom, there should be some sense and some meaning for the storage to occur, and that is a challenge to the teacher. How do I make sure that the students can make sense, and how do I make it relevant to them so that they find meaning for it? And one of the ways we expect students to find meaning is to be certain that the curriculum contains connections to their past experiences. If it is not related to that past experience, is something very strange and new that is here being presented, it won't find, the students won't find any meaning to that. So, it is not likely to be stored in the long term memory. So, when students make connections between subject areas by integrating the curriculum, it increases the meaning and retentions, especially when they recognize a future use for the new learning. So, what does this mean? The way the courses are designed, how they are interconnected, how one becomes a prerequisite to the other, the sequencing, all of them will have to be very carefully designed for the student to find meaning. If he does not find meaning, he may pass, he may get still a grade, but none of that information will get stored in the long term memory. As we already said, long term storage, they will not be stored as a whole in one place. Different parts of the memory are stored in different sites, and they get reassembled when the memory is recalled. And once again, any numbers that we give are only indicative. If a learner cannot recall new learning after 24 hours, you wait for something for 24 hours, if he cannot recall, there is a high probability that it was not permanently stored and thus can never be recalled. That means at the working memory level, all your other factors, either threat factor or emotional factor or non-attention, whatever it is that it has rejected that, and then after 24 hours you will not, one does not remember. That means it is not permanently stored at all. That means the student is expected to again go through the whole process if that something is important. You are wasting an opportunity to learn, because that experience is wasted. You have to go through that experience once more on your own if you are required to do that. For example, reviewing the material just before test allows students to enter the material into working memory for immediate use. That is some of the teachers participate. but that is no guarantee that it is actually stored in the long term storage. That means it may be adequate to pass the exam or to perform okay in the exam, but that information is practically forgotten. I am sure that teachers find it very common. Somebody says, I have learned something in the 2 semesters earlier and I do not remember anything related to that. Okay. That is precisely because the content is not related, they are not connected, and the student has not gone through the entire process of transferring working memory to the long term memory. And here long term memory and long term storage are different. The memory is put in the there is a long term memory, but how it is stored, where exactly it is distributed, how they are connected, what is the storage mechanism, that is very different. We do not have to really fully understand how the storage mechanisms work, but some features of that, if you are familiar with that, then possibly you can also train yourself in the retrieval process. Now the total of all that is in our long term storage, whatever right from our childhood, whatever information that is stored in the long term memory forms our view of the world and how it works. That is what we are. So we are what our long term memory is. Okay. And this total construct of how we see the world is called cognitive belief system, the entire thing. The thoughts and understanding that arise from the long term storage, because we have experiences from variety of at various times, and our experience also varied, but all of them are somehow integrated in the individuals. So what happens, they can be combined in so many different ways, and so the thoughts and understanding that arise from long term storage are greater than the sum of individual items, and if you keep accumulating more items, the number of possible combinations also grows exponentially. That is the nature of that. Just let us recheck what it is. That is where we are calling this triangle is what we call all the long term storage is a cognitive belief system. That is what we call. And we now look at, we put a face here, what we call self concept. Here we put a positive self concept, but it can also be the negative. This curve can be reversed also. Now that is what self concept, while the cognitive belief system portrays the way we see the world, the self concept describes the way we see ourselves in that world. And self concept can be over from very positive to very negative. If you feel all the time negative about yourself, the way you will process new information will be very different. And this self concept is shaped by the past experiences, and see, people will participate in learning activities that have yielded success for them and avoid those that have produced failures. For example, in some subject, let us say you have done badly and you have a very bad experience with that, and a continuation course of that, which is a follows that course, obviously you will not have that kind of you will not that effectively participate in that, because you have now a negative feel about that particular subject. So teacher wants to carry all the students with him or her. One should be sensitive to the self concepts of the individual student. So self concept determines how much attention the learner will give to new information. And here teacher's capacity to, this should be remembered, even at degree, that is even at engineering college or higher education level, the teacher's capacity to humiliate, embarrass, reject and punish constitutes a perceived threat. I am sure you all teachers do experience that. They have tremendous capacity for that. Some people unfortunately utilize that for whatever reasons, but the students will always see it as a perceived threat. When it is a threat, even the grading that a teacher has to do is also seen as a punitive one than as a rewarding process. So, presence of threat in any significant degree impedes learning, that should be remembered. Teachers can make their classroom better learning environments by avoiding threats. Even subtle intimidation, a student feels he will look at it as a threat, and that has effect on the learning that takes place. So, this is one important lesson to the teachers, to make sure that in no way the students feel threatened. And now we want you to do two exercises. We have talked about sense and meaning. I am sure you would have experienced that students seem to be understanding what is presented, but it does not make any meaning to them, it has no meaning to them. So, please describe two instances of students finding sense but no meaning. You can write maximum 250 words giving that instance where you have felt that. So, two instances, give two instances that students find sense and meaning. Again 250 words maximum each, and if you can share it on this particular you can send it by email to this, we will be thankful to you. That will be a lot of inputs to us to kind of we will share these examples with all of you. And in the next unit we will continue with this how brains learn. We will now talk about learning and retention in the next unit, and thank you very much.